And welcome back to part 2 of lesson 3 on our study of logarithms and exponentials. This is the video on how to graph a logarithmic function. So since it's compared to the exponential function, it's going to look a lot like it, but there's a very, very key aspect as to how it is different. Now, the how to graph is pretty straightforward, I believe. We are going to use what we know of exponential functions in order to help us graph. So we're going to change the equation into an exponential function. We're going to create a table of values, and then we're going to plot and connect our points. So our example is going to be, y equals log base 2 of x. So as I said, we are going to need a table. Table comes in a minute. We are going to change this into an exponential function. So as we learned in the last video, it is the base 2 to the power of y is equal to x. Now, what we did with the exponential functions is we chose exponents to plug in. So in this case, we are going to choose y values. So we're going to plug in -2, -1, 0, 1, and 2, just like we did with the exponential function. Only in this case, we're going to be plugging them in for the value of y and getting out an x. So we know 2 to the -2 is equal to 1 over 2 squared. The negative means reciprocal. And 1 over 2 squared is 1/4. When we do 2 to the -1, that means 1 over 2 to the first. 2 to the first is just 2, so this becomes 1/2. If we do 2 to the 0, we know that anything to the 0 power is always 1. So this is a 1. When we go 2 to the first, that's just 2, and 2 to the second comes out as a 4. So those are the easy ones. Oops. Now, we are going to create some axes, and we're going to figure out what this looks like on a graph, as a graph. So our x values go from 1/4 all the way out to 4, so I'm just going to go by ones, that'll fit. And our y values go from -2 to +2. All right, so we can plug in, or we can plot and connect our points. So our first point is at x is 1/4, y is -2. So right about there. When x is 1/2, y is -1. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. Now this looks like it's going to curve. Oh, that was bad. Let's try that again. And it's going to curve somewhat like that. I'm going to cheat just a little bit. And there we have it. This will not cross into the left side of our graph. It will not cross the y-axis for us, and it will just continue to increase as x increases. So that is the logarithmic equation or function. So once again, change it to an exponential, create a table, only in this case we're choosing y values. We're going to plug in values for y and solve for values of x. We're going to do one more example just to make sure that we understand what is going on here. So we have y is equal to log base 5 of x. We're going to change it to an exponential function. So this becomes 5 to the power of y is equal to x. We're going to write our table. we're going to do the same thing we did in the last graph. We're going to choose 5 values for y because y is the exponent. And we're going to plug them in. So if I plug in -2, I get 5 to the power of -2, which is 1 over 5 to the positive 2, which is 1/25. 5 to the -1, which is 1 over 5. Then we get the easy ones here, 5 to the 0, 5 to the 1, and 5 to the 2. Anything to the 0 power is always 1, 5 to the first is 5, and 5 to the second is 25. So there we have 1, 5, 25. All right, so now the hard part comes in trying to draw our graph. Oops, why did that do that? There we go. So there's no way I'm going to be drawing 25 lines here. So I'm going to go by 5s. 5, 10, 15, 20, 25. And the y values are still from -2 to 2. And we're going to try to do as best as we can to graph these dots. So we have when x is 25, y is 2. When x is 5, y is 1. When x is 1, y is 0. And then we get very, very close. We just know we're going to get really, really close essentially here. Those are really hard numbers to try to graph. That is 0.2. I believe that's 0.04. And that is it. We are going to connect our dots. So this one gets very stretched out very quickly because this is a base 5 problem, just like an exponential base 5 will be very steep compared to an exponential base 2. All right, so again, this doesn't cross the y-axis for us, and it will always increase from left to right for us in what we're doing in this chapter. All right, this is a very, very quick video, as you may have noticed. I am going to leave you with this, and I will see you guys